Aksana Shanus Rochi. I'm from Tripoli department and I have completed my high school from Rajagutara Model College. Thank you.
Thank you, Ritushi.
Good morning, sir. My name is Mamtaina Mamun. I'm from CSE department. I live in Dhaka and I completed my SSC and HSC from Vikarna School and College. Thank you.
Yeah, thank you very much.
Hello everyone, good morning sir. Assalamu alaikum sir. This is Damisa Mahmood. I am from CSE department. I have completed my SSC and HSC from Vikarna School and College. Thank you sir.
Thank you, Lamisa.
Assalamu alaikum, sir. I am from CSE department. I'm Tasina Hassan Reddy. I have completed my HSC and SSC from Ideal School and College. Thank you, sir.
Yeah, thank you.
Assalamu alaikum, sir. It's Rita Shaha. I'm from Narayanganj. I completed my HSC from Samsul Hakan School and College. It's my second semester and I'm from Tripoli department. Thank you, sir.
Thank you, Swati.
Assalamu alaikum, sir. I'm Saniyat Mahzabin. I'm from CSC department. This is my second semester and I have completed my SSC and HSC from Vikarna School. Thank you.
Thank you, Sanya.
Assalamu alaikum, sir. My name is Ikram Ahmed Ryan. I'm from Tripoli department and my college was Dr. Mahmoud Rahman Mullah College.
Thank you, Ikram.
Hello, Assalamu alaikum, sir. I am SM Tasin Tahmid. I am from Khulna. I have passed SSC from Khulna Government Model School and College and SSC from Khulna Degree Islamia College. And now I am staying in Khulna. That's it, sir.
Okay, thank you, Tahsin.
Assalamu alaikum, sir. It's Janadul Firdaus Prova and I am from BBA department. It's my sixth semester and I have received my higher school certificate from National School.
Sorry, I can't hear you, Jannat, properly. So you said you're from BBA department.
Yes, sir.
Then why did you choose this course?
Sir, I'm planning to shift department.
Oh, then it's fine.
Thank you.
Assalamu alaikum, sir. I am Rifat Hassan Samio. I am from Tripoli department. I completed my HSC from Uttar High School and College. Thank you, sir.
Thank you very much, Rifat.
Assalamu alaikum, sir. I am from Dinaspur. My name is Rahik Tahmid and I am from CSE department. I completed my HSC from Dinaspur Government College. Thank you.
Thank you, Tahmid.
Assalamu alaikum, sir. Good morning. I am Sifat Sharif. I am from CSC department and I have completed my HSC from Dr. Mahabur Rahman Mullah College. This is my second semester in BRAC and I am from Narayanganj.
Thank you, Sharif.
Assalamu alaikum, sir. Good morning, sir. Myself Asif. Currently, I am studying electrical and electronics engineering at your respective university. And I am in second semester. I am from Old Dhaka, Gandaria. I have completed my HSC from Wills Lilflower School and College.
Right,
that's all from me.
Hello, sir. I'm Muajib Ashraf. I am in CSE department. This is my second semester. My school and college is Rajagutara Model College.
All right. Thank you very much, Ashraf.
Hello, sir. My name is Minar. I'm from CSE department. I live in Chittagong and I graduate my A-levels privately. Thank you.
Thank you, Minar.
Hello, sir. I'm Tosha Bashir. I'm from Dhaka, and I did my SSC from College of Development Alternative.
Right.
Thank you, sir.
Thank you, Tosha.
Assalamu alaikum, sir.
Assalam.
From Dhaka as well. I completed my HSC from Mahotu Kendriya College. And currently, I'm from CS department.
All right. Thank you.
Good morning, sir. Assalamu alaikum. I'm Minhajuddin. Currently, this is my second semester. I'm from CSC department. I completed my HSC from Hamdard Public College and my school was Bisheshto Munshi Abdur Rauf. Thank you, sir.
Thank you, Minhaj.
Good morning, sir. I am Sibagat Salim Rafian. I'm from CSE department. I completed my HSC from Chittagong Cantonment Public College, and my school was Cantonment English School and College, and this is my second semester in Bragg University.
Yeah,
Thank
thank
you.
you, Rafian.
Assalamualaikum sir, my name is Mohammad Sami Jaman. I'm from CSC. This is my second semester and I completed my HSC from Hamdard Public College and I'm from Dhaka. Thank you.
Thank you, Sami.
Assalamu alaikum. I am Mohammad Saminia sir. This is my second semester. I am from CS department. I completed my SSC from Ideal Student College and my college was Government Science College. Thank you, sir.
Thank you, Sami.
Assalamu alaikum. This is Khalid bin Tahir. I have completed both of my SSC and HSC from BCS Normal Public College. I'm from CSC department and I live in Dhaka. Thank you very much, sir.
Thank you, Khalid.
Assalamualaikum sir, my name is Sami Hantara. I'm from CEC department and my school and college was BCS Nur Muhammad Public College.
Yeah, thank you, Samia.
Assalamualaikum sir, my name is Sambin Alom. I am from CSC department. I did my SSC from Atunji Cantonment Public School and my HSC from Midpur Cantonment Public School. That's all. Thank you, sir.
Thank you, Sham.
Assalamu alaikum sir and good morning everyone. I am Tazar Rahman Swad. I come from Adamji Cantonment College. I passed my HSC from there and currently I'm studying at CSC department and I was admitted into fall 21. Thank you.
Thank you, Tazar.
Assalamualaikum sir. My name is Masrur Shakhat Shayan. I finished my SSC from Government Laboratory High School and I finished my HSC from Dhaka College. Thanks everyone.
Thank you, Sam.
Assalamualaikum. Marshal Ulfat Fatima. I done my SSC and HSC from Holy Cross School and College. I'm from Old Dhaka, Nawabari. I'm from CSE department. Thank you, sir.
Yeah, thank you, Wilma. Yes, is there anybody left?
Yes. Assalamu alaikum, sir. My name is Mubashir Tawhid. I live in Dhaka. I'm from CSE department and I finished my levels from Penfield High School. Thank you, sir.
All right, so one thing actually, Mubashir. Your name is Mubashir, right?
Yeah.
Yeah, you should change your name in your, actually, because there is the issue. Please give your official name in your that ID. Otherwise, it will be difficult to take that attendance. Those who didn't use that name properly in your ID, it will be difficult for me to trace out. All right. Next. Who's going to be the next?
Assalamu alaikum, sir.
Assalam.
I'm Samricha Shakur and I'm from CSE department and I have completed my HSC from Shahid Biruttum Lieutenant Anwar Girls College. Thank you.
Yes, thank you, Shamrin.
Assalamu alaikum, sir. I am Anirudh Thoyam. I am from the CSC department and this is my second semester. I completed my levels from Wills Flower School and College. Thank you.
Yeah, thank you, man.
Assalamu alaikum, sir.
Assalam.
I am Arafat Zaman. I'm from CSC department. This is my semester and I completed my levels from Wills Little Flower School and College. Thank you, sir.
Oh, thank you. Thank you, Arafat. Yes, is there anybody left?
Assalamu alaikum, sir. My name is Nausin Darhanum Khan and I've done my HSC and SSC from Vikarna Samam School and College. And
Yes, Nausin.
and I'm from CC department.
All right, thank you very much, Nausin. Yeah, sure, Fairuz, you can leave. So, and take care yourself.
Okay, sir. Thanks.
All right, is there anybody over here who didn't introduce his or herself? Fine. So, most of you are actually, I think, in the second semester in this university. That's great. So it would be helpful for me in some sense that you know that there are some changes in this semester, right? So basically, we are planning to go back to our campus, but for the COVID situation, we cannot do that. But still, we are hoping that we'll go back to our campus because authority give us an instruction up to the March. We'll continue this online semester. After that, if the situation is going to be improved, definitely we'll go back to our campus. On the basis of that, basically, uh, we need to some change in this semester. You know that right now this your live session is mandatory because there are some attendance will count from this live session. Unless you do not present in this live session, you are not going to be counted as a present in this live session, as well as there will be some marks if you present in this live session, because this is a rule for the BRAC University. If you are not present in your class 70%, then you will be not eligible for seat for the final exam. That's the rule for this BRAC University. If you are present 70%, you will get 1 marks. And there is some that way they divided that marks the 5 marks. We also allocated that 5 marks for this live session. I'm going to just give you that idea of how we divided or distributed that marks, 100 marks for your this course. This is actually that we decided in our team meeting. So attendance will be 5% and quiz will be 10%. I'm coming to that discuss for the topics. Assignment will be your 25%. Lab, that is the lab with this course, integrated lab, that will be the 10%. Your midterm will be 20%, and final will be 30%. That is actually your 100 marks will be distributed for this course. And there are some issue since we are hoping that we'll go back to our campus after the March. So then in-person class, definitely attendance would be a big issue. We'll follow that instruction properly. So if we can go back to our campus, but because 70%, once we go back to our campus, definitely we'll follow that rule that existing was in that university. But in the case for this in online semester, how we are going to set up the cutoff number? So that's mean whether it would be 70%, because someone proposing 50% or 60%, still that is not decided by our course coordinator. That's why we cannot say that it would be the 70% or the 50%. Still, we have actually a backup point actually. So that's why we cannot come to a decision what would be that one. Hopefully, by the next 2 weeks we can decide that one, because there are some issue if we mandatory that it would be 70% on that. Some student they have a genuine reason. Sometimes they could not be joining this online semester due to some technical issue. So on the basis of that point, actually, still we are thinking about what should be that cutoff point, whether it would be 70% or 60% or 50%. That would be decided by next 2 week, hopefully. Then we can actually inform you through the class. And the quiz, that's 10% will be carry. We will take through when we are in this online semester. We are going to take this quiz through your BUX. I send you an email. You have to join Slack and also the enrollment link of the BUX, right? Did all of you join or enroll into the BUX? Is there anybody over here who didn't still join into the box? So please, if you still do not join into that BUX, try to join by this week, because we have to uh, somehow connected this course throughout the BUX. Right now, you have that idea. In the previous semester, we are totally dependent on the BUX. BUX means we have created some video and we then upload it into the BUX, and you have to go through that video, right? That was the procedure of the previous semester. Right now, there are still those material are over available over there, but right now it is not mandatory. You have to go through that video. That would be for supplementary for you, because right now there's topics I'm going to discuss over here. So that's why this live session is going to be mandatory for you, but that box is not going to be the mandatory. Mandatory is the sense you don't have to go through that video. If you want, you can go through. And there are some pop quiz also over there. That pop quiz is also for right now for your practice. And still then question is why we'll enroll in the BUX, right? Question will automatically come. Then what is the purpose of the BUX? The purpose of the BUX, there are two reasons. One, we have to take your quiz through that BUX. So unless if you do not enroll into the BUX, you cannot give your graded quiz, which is carry the 10 marks. So up to the marks, we are expecting that at least we will take the 3 graded quiz. So you will miss that one if you cannot enroll into that BUX. And second thing, still we are not certain that we can go back to into our campus. If the situation is not going to improve after the Mars, then it would be difficult for us to go back to into campus. Then we have to again come back to this online session. So that's why, for a safe reason, we are asking you two guys to enroll into the BUX. That is about your box and about that thing. And there is some portion of your assignment. Assignment will give you some on the basis of your topics we are going to discuss in this live session. And hopefully by not by twice in a week we are going to deploy a assignment, because there will be also a lab. They will also give you some assignment, and the lab will be online. Whether we can go to the in-campus, go back to our campus or not, the lab for this semester is going to be totally in online. So there are some different channel in the Slack. You have to join. I hope all of you already joined over there, because anything related to the lab, they will post in the lab channel. So you have to also join over here. You have different channel for different purpose actually. In your general channel, we have some channel actually for say announcement that will be announced, will given by the faculty, anything related to your course. Do not try to post anything into that announcement channel. If your issue there is a general issue, you can raise over there. We have a problem solving channel, anything related to the that problem solving, you can post over here. You have the lab channel, and you have also section wise channel, right? Anything related to your section, which is 8, I'll post it into that section channel, not in the general channel. So that's why you should join over there. And for the lab, I'm saying that one actually lab, they will deploy this lab assignment and theory assignment in alternative week actually. So that is actually our plan. We are going to uh, run in that way actually this semester. Let's see what happened after the meet. So after the meet means after the Mars actually, because whatever the case, actually university has a policy that they decided they will take the meet and the final in campus, whether the COVID situation is not going to improve or improve. Say they will take this midterm in campus actually, but I don't know how it will happen. Let's see what happened, and we are expecting that the situation is going to be improved, definitely then we can add this thing into our in-campus situation. That's all for your marks distribution about this. Is there any question over here?
Sir, please enlighten us about the quizzes. If there are multiple choices, or is there any other portal to attend the quizzes, or we can attend them in the box?
Not really, actually. So multiple choice, probably I don't know what would be there. In the previous semester, sometimes we give you that some multiple choice, and sometimes also probably we are also give some analytical problem that would be also in the multiple choice format actually. Probably because
Thank you,
since
sir.
it's carry 10 marks, it would be mostly multiple choice and conceptual part. If we give any problem or analytical part, that would be also given in term of multiple choice.
So one more question. If the quizzes vary from student to student, or we can attend them in a group?
No. This is individual. You cannot attend in a group.
Thank you, sir.
Yes. Is there any question in this part?
Sir, I have a question.
Sure.
Sir, won't pop quizzes won't carry any marks this semester?
No, right now this semester there will be no marks for your pop quiz. That you can all see only you can use for your practice to understand your topics. That will help you in that way.
Sir, total how many quizzes we have to give?
Probably at least four. At least four. If we get the time, we'll take, because that's the rule at the Brack University. You have to take n+1 quizzes and indicating actually the credit hour of your course. Since it's a 3 credit hour course, we have to take at least 4 quizzes, which is n+1. If we get the time, extra time, definitely we'll take more than that. The last semester, we have arranged 5 quizzes actually, for 5 graded quizzes. 5 graded quizzes, 5 assignments. All right, so is there any more question?
Sir, will the class recordings be available?
Yes. So class recording will be available after basically we'll record this session and after that I will post that link into your Slack channel.
Okay, sir. Thank you.
But remember, live session is mandatory and I will count that attendance. I don't know whether I will count. Either it could be at the beginning of my class, it could be at the middle, and it could be at the end of the class. That's not going to be fixed. At different class, I will count the attendance at different time. Once you miss that one, please never request me that give me my attendance. So that's why take it seriously. I'll also follow that instruction of that course they have given us actually. Right now there will be no issue about your which actually they happen. Students sometimes make excuse about the traffic jam in the road. So I hope that type of situation is not going to arise over here. That could be a technical issue, whether you can join or not. That could be that could be happen sometime. But most of the time, I hope you can join in the class on time. All right, so now I'm going to talk about the topics of these courses actually right now over here. Since it's a 3 credit hour course, the content of this course actually very big. There is a reason basically when they designed that course actually at the time the university have a bi-semester system. So when they transfer from bi-semester to the tri-semester, they didn't actually update the syllabus. So that's why that content is given in the website. It would be not possible to cover all the topics. We can mostly cover actually in this online semester from my previous experience, previous 2 or 1.5 year experience, we can say we can mostly cover the Newtonian mechanics part and some portion from the properties of matter and some part also from the waves and oscillation, because your course contain actually mechanics, properties of matter, then waves and oscillation, and then also some part of your thermodynamics, which is a very broad syllabus. Because that was for 6 month semester, that was fine, that could be covered, but in this 4 month semester it's quite hard to go through all the topics. So that's why mostly we'll focus on the Newtonian mechanics part over here. And the topics actually not new for you. All the topics I'm going to talk about over here is definitely familiar to you, but presentation would be a little bit different actually. Different in a sense, we are not going to give you any definition or the derivation in the exam. The exam means I'm talking about your assignment, mid and the final would be basically mostly problem solving part. So that's mean whatever you are going to talk about over here, you have to basically apply those things in our real life problem. That is our target for this course. For doing those things, actually, you have to be very careful in a sense. Unless you do not understand the topics properly, then it would be difficult for you to solve those problems in the assignment, mid, and the final. Because sometimes we set up a question so that to solve that question you need more than 2 or 3 idea. So I can set up a question where you need to apply the idea of the work energy, momentum, and also that 2D on the 1D motion. So Newton's law could be, all of those things could be actually that apply in one problem. So that's why you need to do practice, because practice makes a perfect, right? So that's why it is required to do a lot of problem. I'll try in my live session, try to do the problem solve as much as I can. But there is some issue. That's why I'm saying that please join into the box. But in box there are some problem solving video. You have to also access those one over there. Probably those problem I'm not going to discuss over here because it is already recorded. I uploaded into the box. So that will be also helpful for you. And for reference book, we'll follow Resnick Halliday Walker, which is the Fundamental of Physics, which is a very good book at the freshman level. And we'll also, which is the 10th edition, I will also provide some suggested problem from that book. So if you can do those problems, it will be definitely help you a lot in the exam time. That's it from my side about this course content actually. And if you my prescription for you actually, if you want to get a good grade from this course, you have to be very regular. You have to be very regular, otherwise it's very difficult. So although I know that it's the online semester, you guys do not take it very seriously. From my 1.5 year experience, I can say that some guys actually they don't care about this course, but at the end of the semester they become actually that they understand what they did actually for the semester. Otherwise it's very difficult. Don't take it lightly actually. Definitely you have to give the 100% effort to grade. So if you're very regular, definitely you are going to get a good grade from this course. Yeah, that's it. Is there any question over here?
Sir, I have a question.
Sure.
Sir, the book you suggested right now, it is not available on Box. Where we can get it?
So these books we cannot provide into the box because there is a copyright issue. So one thing you can do, you can buy this book, which is will be, because same books that we are going to use for your second course, Principle of Physics 2, or you can collect it from soft copy that is also available in the online. Because I know you are guys very smart, you can find it from the online. And I have that as soft copy, but that I cannot upload into the box as well as the Slack for the same copyright issue.
Sir, can you give it us on Drive?
Yes, for that one actually you have to give me a mail. Give me a mail in my email address. I will try to reply you with that book actually because yeah, I can share that one through the Google Drive actually. For that one, I need your email.
Thank you, sir.
Sir, can you please provide us the names of the books?
Fundamental of Physics, Reasoning Holiday Walker. It's a 10th edition book.
Thank you, sir.
All right. So, is there any more question? So, if it is not, then can I start my topics?
Sure, sir.
Yes, sir.
Sir.
Yes.
Right. Thank you very much. All right. Can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
That's great. All right. So today we are going to talk about vector and scalar. Although this thing actually you are learning from your school life, but still we going to talk about this thing at the very beginning of this course because it is very important. You cannot never neglect this vector and scalar quantity in every single step of your life. So for example, if I ask you why you are at the BRAC University or at the CSE department at the BRAC University, probably you are going to say that you are going to be engineer after the 4 years completing your successful university life, right? That's your target or that's your direction. So that's why you are actually at the BRAC University, which means that's a vector, right? If you do not follow that instruction, you can never reach your destination, which is a vector. So that's why vector is very important in the field of science and engineering. So in every single step, you have some target, which is basically the vector. So fine. So we define the vector is basically a mathematical quantity which has both magnitude and the direction, and scalar has only the magnitude, right? That's how actually we define the vector. For example, you can say that velocity is a vector, whereas speed is a scalar quantity. So if I say a car is traveling, say this is a car which is traveling with moving with say that 5 meter per second, then I can say it is will be the speed because I didn't mention which direction it's moving. I said only the 5 meter per second, so that would be the speed. But if I say it's moving with 5 meter per second towards the north, then it would be a velocity of that car, which is a vector because I mentioned both magnitude and the direction. That's how actually you differentiate velocity and vector and scalar. Fine. Now, this vector and scalar we represent in the two way, graphically and also mathematically. Mathematically is very much familiar to us because we know if we express a vector in that way, so say that 5i hat plus 2j hat, that is the mathematical expression of the vector, where I and j basically the unit vector. We talk about this thing later, and this is actually the mathematical representation of the vector we use, and we are very much familiar with this system. There is one more way we can express that vector, which is graphically. To represent the graphically, we use a length. So this is a length, and we also use a arrow. This length is going to be indicated is basically that magnitude, and this arrow is going to give you that direction. That's how actually we express the graphical representation of the vector. And mostly graphical representation actually is a very much very important or very useful actually. So if you understand graphical representation, then without doing the calculation, at least you can predict or you can say that resultant direction of that some vector. So that's why it is very important. So that's when without doing that calculation, you can say the direction of that resultant force, which would be like a magic to me. So that's why the graphical representation, I will first talk about the graphical representation, then after that I will talk about basically the mathematical representation of the vector. Fine, and there is a convention actually in the book we use a overhead arrow to express the vector, right? And sometimes we use the bold letter actually, and sometimes you will find out there is a arrow beyond the letter. The mostly we use the overhead arrow actually. Fine. So there are different type of vector actually. We'll talk about say sometimes we will talk about say that it's a positive and negative vector. What is that positive and negative vector? What do we mean by that? Say if I choose any direction is positive direction, say for simplicity I choose that direction is positive, I use, then any vector towards that direction I'll consider that would be a positive vector. Any vector towards in the opposite direction I'll consider that is a negative vector. It's just a convention actually. You can choose the opposite direction is positive, then in that case this would be basically positive vector and this would be basically in that case is the negative vector. Fine. Then there is one more vector we talk about, which is say that parallel and anti-parallel vector. One more thing, my handwriting is too bad. Do you understand this thing properly? If you can
Yes, sir.
if you can understand, please ask me. And sometimes I also write down intentionally somewhat in a complex way so that at least the student asks me, sir, what you have write down over there. That happen actually mostly actually in the in-person class. Student doesn't ask any question generally, which is not good habit actually. I at least encourage a lot of question. You can ask any question on your topics except my personal question. In that case, if you, I'm going to be hesitant actually. So that's why sometime doing that thing actually my handwriting become bad day by day. All right. So what's parallel and anti-parallel vector? Basically, say you have a vector towards that direction and another vector is also towards the same direction. Say this is the vector A and this is the vector B. Then these two vectors would be parallel vector. Why? The angle between that two vector is basically 0 degree. This is the mathematical condition for the parallel vector. You can find out, say if you somehow superimpose the vector A on B, you'll find out there will be no deviation between these two lines. So that means the angle is 0. What about that anti-parallel vector? So if one vector is towards that direction and another vector is towards in the opposite direction, in that case the angle between these two vectors basically is 180 degree. Right, so you can say, so if I superimpose the vector B over here, so this is the new location of that V, then the angle between these two lines is basically the 180 degree. So that's why the for anti-parallel vector would be angle would be must be 180 degree. It's not required that always the magnitude of these two vector would be equal. Sometimes it could be equal, sometimes it could be the different. There is one more vector we talk about which is null or zero vector. What is that? Which has a zero length basically. So that's why we talk about this a null vector. Say I have a vector A and another vector is the B, is same magnitude, but these are basically the anti-parallel vector. They are in the two different directions. Or I can say in mathematical, that's going to be helpful for you. Say if the A vector is 5 I hat, then B would be basically minus 5 I hat. Since I say there's an equal magnitude, so that's why both unit I take that 5. One is the positive vector, then another would be basically the negative vector. Fine, then if I add them together, if I write A plus B, which is going to be basically 5i minus 5i, that's going to be giving me the 0, which means that it has a 0 length, right? That's how actually we can find out that null vector or the 0 vector. Fine, say I have a vector is A, which I take, look at this, I take this smallest box, actually the single unit. Now, if I want to draw the 2A of that vector, so that means I'm going to multiply this vector A by a scalar quantity 2. It means that I have to double that magnitude, right? So this is single unit and this is the double unit. So that should be basically that twice A. So that means I can multiply a vector by a scalar quantity. I can also do, say, reverse the direction or flip the vector. If I say that multiply by minus 2 of that vector, it will just would be basically a negative vector. It will flip its direction towards in the opposite direction. So that's how actually we can do the multiplication of that vector. We'll talk about this thing, how we're going to do. There are some properties of the multiplication of the vector. We'll talk about this thing. What about, say, that addition? If I want to add two vector, say that vector A and B, how I'm going to do that? For that one, say I'm going to draw an idea. Say that I have a table. Into that table, there are 2 points. Say one point is over here. This is the point A. And another point, say over there, which is the point B. And you are standing at point over here at point A. And you want to go from point A to B. So probably we're going to follow that shorter distance between the A and B, right? So that you have to do less amount of work. So you will follow that path actually over to go from A to B. When you start from point A to B, at the same time, say that the table can move from left to right towards that direction. If this happens simultaneously, you will find out that after reaching point B, you will see that you are basically standing another point, say that point C. Do you understand my point? Try to understand this thing. So when you start at the point A towards the point B, at the same time, if the table moves towards that direction, towards the rightward direction, then after reaching the point B, you will actually find out that you are actually standing at point C. Someone at, say, that outside of that frame, he will observe that basically you are reaching at the point C, which means that basically you go from A to B. You're right, absolutely. But at the same time, B is changes position from B to C. Actually, your displacement would be basically from A to C, right? You understand my point?
Yes, sir.
Yes, sir.
Which means that I can write this displacement in a sense AB plus BC would be equal to AC, right? So that's mean if I express this AB length by a vector, say that vector A, BC by a vector B, and AC length by a C, then I can write this AB, A plus B plus would be equal to the C. A plus B I can write equal to the C, which is actually the story behind the adding two vector. That's how we are going to basically add two vector. And this is a law which is a very fundamental, or you can say the very useful law. That law is known as vector triangle law. Very useful and very powerful. Remember, only the law I'm going to use after your motion chapter, motion in 1D and the 2D. It's very helpful, this law. So that's why I'm emphasizing this law actually. And remember, when I'm going to make something box on that, that's mean that information somehow you have to carry in your head. That's important for you actually. So this is one of them actually, the vector triangle law. So using that law, we can add, subtract, we can express a vector, and anything we can do actually. Motion in 1D, 2D, that's going to be helpful to understand using that law. So, but to use that law, there are some rule. Rule means, say, I have a vector over here, I write, so this is the vector A, and another vector is B. Then I can say that the resultant vector will be towards that direction, right? It's similar to that. Look at this. I write A to B vector A, B, and C. To use that law, you have to care about that vector A and B in such a oriented that head of the vector A is connected to the tail of the vector B. Or I can say head of the first vector must be connected to the tail of the second vector. This is the first condition. We say in that way it is head to tail connection. It is head to tail connection. It has to be, otherwise you cannot use that vector triangle law. Second one, look at this. If I start to move from A to B, if I start from move A to B, I will basically move in a counterclockwise direction, right? Then the resultant would be basically the clockwise direction. If I move from A to B, from in that path is going to be basically the clockwise direction. Or sometimes it could be vice versa. Say if the vector is oriented in that way, say this is that vector A, this is the vector B, right? Then resultant will be towards that direction, which is basically right now counterclockwise direction. That's are the two conditions to use for the vector triangle law. Very important thing actually. Right. Fine. Then what would be the situation? Say I have, in every case, I'm not going to find out in the real life case, I'm not going to find out the vector would be in such a direction. Say one vector is over here, another vector is over here. Say the vector A, this is the vector V. Or sometime you will find out that situation, say this is the vector A, and say this is the vector B, right? Or it would be this way, say this is the vector A, and this is the vector B. It could be happen, right? Anything could be happening in our real life case. I do not know. It's not true that always I'll find out the vector in such a way that they are would be head to tail connection. Then what I'm going to do over here? For the first case over here, in all situation actually, say if you have a vector over here, sorry. So this is the vector A, and say I'm going to shift that vector from here to here. So if I shift that vector from that point to, say, from that point to, I'm sorry, from that point to that point, is the vector is going to be the change over here? Hello?
Sorry, sir, I can't understand the
So
question.
question is, say this is the first location of the vector over here. So I just
Yes, sir.
shift that vector from here to here. If I shift, is there anything is going to be the change of that vector?
No, sir.
No, sir.
No, sir.
So that's when it will be the remain same, right?
Yes, sir.
Since I do not
Yes,
change
sir.
its magnitude, I do not change its
Or the
direction.
direction.
I just shift the origin of that vector. It means that vector will be the remain same. That means you have that power without changing the magnitude and the direction. You can shift your vector anywhere you want. You can do that. If you do that, your vector is not going to change. So that's when the vector is remain same. If I can do that, then definitely I can place this vector over here. In that case, it will be basically head to tail connection. Definitely in that case, I can use my vector triangle law. In that case, definitely this would be your resultant vector, which I write it should be sum of A plus B, right? What about this case? Say for this case, I'm going to extend any one I want. Say I'm going to say that extend say B vector from here, or it's not going to work. Say I'm going to basically extended that B, you can say in that way. So in that case, this is will be basically that new position of the B, then there would be head to tail connection. I should use the different color. So this will be actually that head to tail connection. That's when I shift that B from here to here. They would be head to tail connection. Same thing I could do over here. So I can shift A from here to here, right? I can shift the origin of that vector A from here to here. Then the A and B again would be head to tail connection. I can say this would be my resultant vector, which is would be B plus A right now, because B is the first vector, which is head is connected to the tail of the second vector. I write down, look at this head to tail connection, the first condition. Head of the first vector must be connected to the tail of the second vector. That's the condition for the use for the vector triangle law. That's how actually we can find out the, or we can add the vector in graphically. And we can also write, say, the case actually we arise over here. Say, I have this vector A, and this is my vector B, right? Then I know I'm going to add them together in that way, A plus B, which is give me that addition of that vector. I say that one using the vector triangle law. That's fine. What about, say, if I subtract these two vectors, say I want to find out, I want to know what would be the direction of A minus B. If I give you the number, say A is 5i plus 3j, B is actually 2i minus 1j, and definitely you can find out that subtraction of that very easily. But can you visualize the resultant direction of that A minus B? Can anyone visualize in your mind?
I think it's minus A minus B.
Yeah, so that's actually you're talking about, but I need to actually visualize. I can. It would be that you can visualize the direction. Resultant direction would be in which direction?
Same magnitude of B but opposite direction.
So the B will be on the opposite direction?
Yeah, B will be the opposite direction, but I want to know the A minus B direction. All right.
Opposite.
opposite of A plus B.
Opposite of A plus B. Look at this. This is your A plus B, right? Thank you very much. At least you try. That's appreciate. I appreciate that one. Look at this. To find out actually the A minus B, do you think do we need another theorem or another rule to find out that one? No, I'm not going to use another rule over here. What I'm going to do actually, say if you write, say if you give your instruction in the computer, say that if you give the instruction 5 plus 3 or 3 plus 5, actually there's 7. When you say that 3 minus 5 is automatically give you the 2, right? Minus 2 actually. So remember, while doing this operation, computer doesn't going to use different logic or different program. It uses the same program, but in a different way. So when it's right, say it basically also giving the minus 2, but it actually adding these two number, but they use a minus sign in front of that. Basically adding. So that means these two operations are performing using the same logic, right? Same thing we are going to do over here. So if I want to find out that A minus B, what I'm going to do is someone actually probably giving the knock. Yes, Asif, do you have any question?
So sir, we have to change the direction of B vector.
Exactly. I'm going to flip the direction of that B.
Okay.
So I'm going to change the direction of that B. So I'll just multiply by minus 1. Right. So this is to be my minus B is flip its direction. Then I can say this is my A vector, which is head, is connected to the tail of this minus B. Then definitely this is will be my resultant vector, which is A minus B, because in that case I'll write my vector triangle law, A plus second vector, which is minus B, which is actually give me A minus B. Right? So that's mean I'm using my vector triangle law over here, because the only law still I know. I'm going to use that one step by step. So that's how actually I can find out that, or I can subtract the vector, add or subtraction of vector using the vector triangle law only.
So that basically means if we want to subtract two vectors, we have to put the tails together.
Tails to together means no. It's oriented. Look at this again. The head to tail connection.
So okay.
So
Yeah,
I'm coming to that point also. Whatever you raise, say you say if the two vectors are oriented in such a way that they are tail to tail connection, right?
Yes, sir.
Say this is one vector. Say that vector A. Say this is another vector, is the B. They are right now tail to tail connection. So what I can do one thing. I can say the shift the vector of the B or whatever you want. So first I shift the vector B, right? Then this is actually head to tail connection. I can say this is would be my this is would be my resultant vector A plus B. I can write it would be A plus B. Let's say this is actually the C. I express by this is C. Right? I have to rearrange in that way. But what about say someone say no, I'm not going to shift the B. I'm going to shift instead of B. I'm going to shift. Say that A. Then this is would be actually that position of vector A. Again, they are head to tail connection. I can say right now it would be B plus A must be going to be C. It's the same vector, right? This is would be the same resultant vector. So that means I can write A plus B equal to B plus A. This is another law we term it. This is actually known as the commutative law, which is also the
Sir,
use or extended version of the vector triangle law. Yes.
So can I see the previous math on the red color?
Red color?
Yes, sir. The previous one, the subtraction one.
Yeah.
Sir, actually, we are adding the negative version of vector b. So if you look at that, if we subtract a from subtract b from a, that's actually putting the tails together. I cannot understand this part.
So look at this. This one actually your vector a, right? And this was actually vector b. And they say that if I take the resultant of these two one, it would be basically your a plus b according to the vector triangle law, right? Would be that line. This would be your that line. So direction would be towards that direction. Now I say that my intention is to find out actually a minus b. I'm going to find out a minus b, which direction it would be. That is my intention. To find out what I did, I just flip the direction of vector b. That is become actually that minus b. In that case, you can say that this b would be not present over here because I already shifted that direction. Right? So in the right now, look at this. This is my vector a, and say this is my vector minus b. It's not bit right now. It's a minus b. They are again head to tail connection right now. Then I can use my vector triangle law. This is the first vector, which is a, plus the second vector, which is minus b, and definitely this is going to be my resultant vector in that case. Then this is actually your direction, which is a plus b would be basically minus a minus b over here, which is actually the subtraction of these two vectors. You understand right now? Oh God. Hello.
Yes, sir.
Hello, I'm sorry.
Yes, sir, we can hear you.
Yeah, I'm sorry. So do you understand right now?
Yes, sir.
Is it clear to you?
Yes, sir.
All right. So fine. That's great. So this is actually the extended version of your vector triangle law, which we say that is a commutative law, because you are familiar with this format. Actually, you know that if you have two vector in such a way.
Sir, you haven't shared your screen.
Oh, sorry. Thank you very much.
Sir, we cannot.
Yeah, there is some network issue from my side. Now, can you see it?
Yes, sir.
All right. So,
Yes, sir.
and we know that one, right? If you have a vector p and vector q, then you know that the resultant would be in between that two vector, which is written by the r, and this comes from this vector triangle law again. So only law, which is a very beautiful law actually. Someone giving me a message in the chat box. Yeah, what you did, Mohammad Shoaib Dewan? Where do you think you are a why you are sharing your social platform over here?
So he asked to join the messenger group. That's why he shared his Facebook
No,
profile.
you cannot do that one. That's strictly prohibited. Don't do this one, please. If you need anything to discuss, try to come this live session. Not at the back side. Come to the front side. Please do not do this thing. It will be really we discuss those things actually. You don't have to discuss over here. If you want to discuss, come to this live session, raise your question, we'll discuss, because definitely someone, if you're asking that question, someone has also that question in his or her mind. They are also going to be benefited for that one. It's not required to use any messenger group. All right, so this is actually that another version of thing. We extended version, we say that a commutative law. What if say if I have more than two vector, so in such a way that I arrange, they are actually not in that orientation in real life, say, but I arrange that one to use my find out that resultant vector. Say this is vector A, this is vector B, and say this is vector C. I want to find out resultant of these two vector. All right, I can do that one because I have that powerful law, vector triangle law, that I will use step by step over here. First, I will add A plus B because they are head to tail connection over here. I can say this is should be my resultant A plus B vector. In that case, I can neglect these two A and B separately. Then with this A plus B, C is again head to tail connection over here, right? Then I can use my resultant vector over here. So this is would be that resultant, and that one I can write the resultant would be A plus B plus C, which is actually that one. So you can do another way actually. Instead of adding A and B first, someone can say that say he will add B and C first. So this is actually your V vector. They are again head to tail connection with that one. If you do that, you will find out this, which would be actually your B plus C vector, right? In that case, B and C you can neglect that one. With respect to this B plus C, A is again head to tail connection over here. This is the head of the A and this is the tail of the vector B plus C. In that case, I can say again this would be the resultant vector, which I can write that vector would be A plus B plus C. Now A plus B parenthesis plus C and A plus B plus C is the same vector indicating, right? The same vector. So that's how we can write this one A plus B plus C must be equal to the same vector A plus B plus C. This is also another law we call, which is actually called known as the associative law. Associative law, which is also the extended version of the vector triangle law. We will use that one in step by step. That's all from today because your time is up. Do you have any question over here?
Sir, I don't have any question.
All right, so if you don't have any question, yes? Fine, if you don't have any question, you can leave, guys. Today, I'm not going to give you your attendance. I will take it from the next class. Do you have any issue if I give all of you the attendance today?
No, sir. That would be great.
Yeah,
actually.
this is for the. I know you guys are very generous about that one. So this is only for this today. From the next class, I will also call your attendance. Thank you very much. See you in the next class.
Thank you, sir.
Yes, sir.
Thank you, sir.
Awesome. Stay safe. Do not go to the outside unless it is necessary, guys.